Okay, so let's look at numbers 8 and 9 on this video. Hopefully we'll get to both of them. All right, so I'm going to turn on my draw feature. For number 8, we're going to find f composed with g, g composed with f, and the domains of those functions. And we have fractions. So let's go ahead then. And let's start with, and I don't know why I'm hitting the draw feature, but it's not seeming to want to draw. That's weird. Let's just, okay, now it's doing it. All right, so f composed with g. Let's notice that f is 8 over x minus 3. So let's put parentheses into the x in the bottom. And now we're going to drop the second one in our notation, g, into those parentheses. So x over x plus 1. Now remember, with these fractions within fractions, we have to simplify them. To simplify them, we multiply by the denominator of the smaller fraction. So here's my little fraction within the big fraction. That denominator is x plus 1. We're going to multiply by x plus 1 over x plus 1. And of course, I'm only multiplying by 1. I'm just writing it as x plus 1 over x plus 1. Anything over itself is 1. So we're just changing the way it looks. We're not changing our answer. So 8 times x plus 1 will be 8x plus 8. Don't forget to multiply times both terms. On the bottom, x plus 1 times the fraction. This x plus 1 will cancel with this denominator, so we'll get just the x that's on the top. Now don't forget, the minus 3 has to multiply times the x plus 1. So that's minus 3x minus 3. And now let's just add these two like terms and we'll be done with this function. So x and minus 3x is minus 2x minus 3. All right, now while we're here, let's find the domain of this function, since that also is part of our instructions, and then we'll go on to g composed with f. All right, so to find the domain of any composite function, we're always going to look at the second one in the notation. So if we look at our second one, g, we need to figure out, all right, what causes us to have a 0 in the denominator? Now you can look at that one and say, oh, -1. But if you're not able to just look at it, or just set the denominator to 0 and solve, and we get that -1 is the thing that makes this 0 in the bottom. We're not allowed to have -1, so we don't want x to be equal to -1. Now we also, though, have to go to the bottom of the fraction here and see what causes us to have that to be -1. Or -1, for that to be 0, because we can't have 0 in the denominator. So let's set that to 0 and solve. And that gives us -2x equals 3. Divide out. And we get that we also can't have -3/2. So for the domain, x can't be -1, and x can't be -3/2. All right, now let's go in the other direction with our composite, since we need to find g composed with f. I'll just change the colors up some, just so we can kind of separate them out. All right, so g composed with f. Let's go to g and put parentheses into its x's. Now g, as I recall, has 2 x's, so we've got to put parentheses on the top and then parentheses plus 1 on the bottom. So parentheses and parentheses plus 1. Now let's drop f into these parentheses. F was 8 over x minus 3. So 8 over x minus 3. All right, now we want to multiply by the little denominator inside to clean it up. So x minus 3 over x minus 3. When I multiply the x minus 3 times the fraction on the top, this denominator will cancel with this, and I just get 8 on the top. On the bottom, when I multiply the x minus 3 times the fraction, same thing happens. I get just the 8, but don't forget to multiply the x minus 3 times the 1. So 1 times x minus 3 is just going to be x minus 3. And then the last thing we need to do there is add our 8 and our minus 3 to get 5. All right, now let's find our domain of G composed with F. Let's notice that in this one, F is second in the notation, so we need to go up and find the domain of F. Well, if we look at the bottom of this function, x cannot be equal to 3. Again, you could set it equal to 0 if you're not sure what that value is, but this one we can see that 3 would cause that to be 0. And then we can also just look at that one and see that negative 5 would cause that to be 0. So we need to not have a 3 and not have a negative 5. All right, looking good on time, so hopefully we can get number 9. So for the function 2x squared minus 3x plus 5, we're going to do some functional values, f of 2, f of negative 3, f of a plus h, and finally our difference quotient. And we might have time for all of it, we'll see. All right, so let's start with f of 2. We are going to stick a 2 into the x's here. So f of 2 will be 2 times 2 squared minus 3 times 2 plus 5. And then let's just work through order of operation. That's 2 times 4 when we square our 2 minus 6 plus 5, or 8 minus 6 plus 5, we will get 7. All right, now let's do f of minus 3 in the same fashion. Can't see our function very well anymore, but let's see, 2 times minus 3 squared minus 3 times minus 3 plus 5, or we can just kind of look up here and replace the 2 right there with a, oh, it should be a negative 3. All right. So again, let's do our order of operations. Minus 3 squared is 9. And we can go ahead and do negative 3 times negative 3 is a positive 9. And that is going to give me 18 plus 9, 27 plus 5, 32. Okay. All right, now let's go to f of a. We're going to replace all of the x's with an a. Now, since I can keep looking back up here, but really most of our function, we're just thinking these parentheses are going to become an a. So I'll get 2a squared, 3a plus 5. Now again, since we're going to do a plus h now. Since I can't see the top function though, I know that I replaced the x's here with a's, so we'll have 2. Let's put parentheses squared, 3 parentheses plus 5. We've replaced our x's with parentheses, and let's drop the a plus h in here. Now the ugly thing here is all the multiplying out. Let's remember that a plus h squared really means a plus h multiplied by itself. And let's distribute the 3, so negative 3a, negative 3h, and I still have my 5. I will FOIL out the a plus h's and then distribute the 2. So a times a is a squared. A times h is ah. Doesn't look much like an ah. H times a is ah. And then h times h is h squared. And then I still have 3a minus 3h plus 5. Let's distribute the 2. 2a squared, 2ah, 2ah, and 2h squared. I'll just rewrite all this. And we can add like terms. Let's notice that 2ah and 2ah can be added together. And now we have the answer to f of a plus h after we write this out. Okay, now the third part of this problem was to do the difference quotient, f of a plus h minus f of a over h. Since I'm going to run out of time if I take too long to rewrite, I'm going to go ahead and just let that be. There's my f of a plus h right there. I'm going to let that be the top of the fraction. And then I have a minus sign followed by my f of a in parentheses. And you can do this on the test too if you wish, just to save yourself a little time. Because of course that's where we're going to use this thing, is in our difference quotient. All right, now we'll put the h on the bottom. All right, now let's distribute the minus sign through the parentheses. So 2a squared plus 4ah, all of this is going to stay the same. And we get negative 2a squared, positive 3a, and minus 5. All of that's over h. And now things start to cancel on us. Let's notice 2a squared minus 2a squared, negative 3a, 3a, 5, and minus 5. Everything that's left has an h in it, so I am going to factor that h out. I'll be left with a 4a, a 2h, and a minus 3. And now I can cancel this h with this h, and I'm left with my difference quotient.